So today we're going to continue talking about functions and domain and range, and we're also going to incorporate how we write an equation when we're given a graph or given a table, and or if we're given a table, can we make a graph and then an equation, and being able to go between situations, graphs, tables, and equations to represent all of the different pieces. So here I have, I'm on page 98. And we're going to start here with number 8. So I know there's some other stuff above that. Unfortunately, we're not going to have a chance to do that experiment. But here, what we've got is data for, we had a spring connected to a cup, and when we put different masses in it, we can measure how far the spring stretches. So first thing we need to do is graph this information. Notice that our independent variable mass, and we have our dependent variable spring stretch is labeled on our graph. That's very important. And if we were to write a dependent statement, we would say stretch depends on mass, meaning that, remember, y depends on x. So I could go through and I could go ahead and graph this piece of information very easily. So 2 is at 6. Yours is probably a little easier to see. Mine is kind of, my lines are a little bit faded. 4 and 12. I have 6 and 18. 8 and 24. 10 and 30. And 12 and 36. And one of the things we need to think about is whether or not we need to connect these dots. We've talked about continuous and discrete data. We could technically connect this line if we wanted to, assuming we're going to use half-gram measurements or even smaller. For our purposes today, we'll leave them disconnected so we can see what's happening here. How much does the spring stretch for each additional gram of mass added? Okay, so guys, remember that is going to be your slope. You should remember that from 7th grade. That change in y over change in x, right? We use the letter m for that. Change in y, change in x. So for every 6 centimeters, it stretches after adding 2 grams. Well, we know we can change that 3 centimeters per 1 gram. So we could write all of that here on number 9, or we could just write 3 centimeters per 1 gram. How did we find our answer? We could check, just go back and look at our table. Change in y over change in x. Can we write an equation for this? They want us to notice, they want us to use m and d. Well, this, if it's 3 centimeters for every 1 gram, does that mean that we are going to write d equals 3m, or am I writing m equals 3d? And this is where we sometimes get a little bit in trouble. So I want you to go back to your table, and we have this 3. Well, think about the pattern from here to here. Well, the grams times 3 gives us the centimeters, and they are wanting us to use m for mass and d for distance. So I can see that I'm going to have to say 3 times my mass to get my distance. So I can say d equals 3m, and it is not the other way around. One of the biggest issues I see every year is we get really used to x and y, and they're wanting us to use a different variable. So if it helps you write y equals 3x and then plug in the necessary variables for independent and dependent, then we can do that. It wants us to find the mass of 1 gram. Gram is m, so 3 times 1. So my d is 3, and it wants us to put that on the graph. Well, we have the coordinate now, 1, 3, because x, our independent variable, is 1 and y is 3. So there it is in the graph. Then it talks about using 7 and putting that in the graph, and 13. So I'm going to let you go ahead and do 12 and 13. You can pause me and then check yourself. Hopefully you came up with D is 21. So you have the coordinate 321 on the graph. Now this one, 3 times 13. So the D is 39. So I have, I'm sorry, this was a 7 and a 21. I apologize. We have 13 and 39 on our graph. Now, what is the y-intercept? 0, 0. Reasonable domain, okay, and this goes back to that continuous or discrete statement. We can very well, again, justify that we could connect these dots, no problem, if we wanted to, because we can have half measurements on our mass. So if I was to go through and say, okay, I guess I do need to draw my little window, my domain, my range, this is going to continue. So we could say my lowest x value is going to be 0. I don't have an upper, and I could say 0 is less than or equal to x. Again, I could write x is greater than or equal to 0. Here we have some data now. What I would like you to do for me tonight is I would like you to look at Mr. Hardiff's class and their experiment. I would like you to finish their table and then answer 17, 18, and 19. And then tomorrow when you come to class, we're going to look at that.